Hello, hi, welcome back to my channel. For today's video, I'm going to show you on how to use this enterprise network monitoring system that I made it from the scratch. This is a custom network monitoring tools that I built myself. So it has a ping portal and it has a trace route and HTTP monitoring and MTR. This is an enterprise network monitoring system built with PHP, Nginx, MySQL, and Python. How they work? They work like if, for example, user will access the browser, what I'm currently accessing right now. Then um, I'm using the Nginx as my web service. Then PHP for the front end and MySQL for my database. And for the back end, I'm using the Python engine. First, I will explain, before I go in detail, I'll explain to the admin portal. In admin portal, um, I can add delete network devices. For example, the purpose of this one, I will add Cisco devices, whether it is a router or whether it's a layer 3 switch like Nexus switches or Catalyst. So because I'm going to use those router, first my server will SSH those devices. Then from those devices, they will initiate ping and trace route. Then I can also set a BRF and source IP for proper routing. Then I have here ping target devices. I can have a IP address to monitor basic connectivity. Then I have trace route targets, destination for path analysis. Then I have also here HTTP targets, URL for web application performance testing. Then one of my favorite is my MTR, my trace route targets endpoints for detailed network path analysis. In a real-world analogy like network operation center, console where technicians configure what to monitor and how often. Why it matters. Without the admin portal, you have to manually edit database records to configuration files, and it provides a user-friendly interface for all monitoring setup. For example, if I want to add devices, I will select, for example, which is my source. In my case, I will select this our layer 3 switch. Then, for example, I will issue a ping for our, let's say, one of our server, 192.168.3. Um, let's say I'll choose 3.7. Then I'll put server 01.ap.local. That's my domain. Then please match the requested format, enter valid IP address 192.168, because there's an extra that here. There's a validation. I create a validation so that you cannot just put whatever you want. Then add. Pings target added successfully. Now we have added. Then you can edit if you want. For example, you made a mistake on the name. I put server 1, then you can save it. Once you save it, it will all display here. Now as a ping portal, this is now it's showing down. So before it will go up, now I'm going to restart the service. I will use so I will restart the service. I'm going to show you. I will sudo systemctl restart ping engine service because I created a service for a ping engine. I'll enter my password. So now the service is started. We can verify that. our service is running. Okay, so if we will refresh this one, 1 hour. Okay, I changed to 1 hour because it was selected as 24 hours. Now we can see here the server is up and server is up and running. Okay, so in our case, hmm, for example, if you want to go in detail here, let's say what happened to that spike. Because this is real time. This is updated current 5C max 255. So is that really a 255? Let's go deeper. All you have to do is select on your mouse, and you can see here. See 255 milliseconds. So you can go deeper. So you can just scroll your mouse, and you can change the graph. You can investigate. For example, this one. You can investigate this one, 281. So yeah, they're matching 281 here, 281 here, 255 here, 255 here. See, it will detect also if it's down or not. So what if we want to check? Let's test it if we um, can we shut down that, for example, we'll drop this traffic for 2.2.2. Let me check. So what we're going to do here, we're going to drop the traffic for that 4.2.2 IP route 4.2.2.2 um, 255.255.255.255. We'll send it to null 0. Okay, so we're dropping the traffic. See, let's see what will happen to this one. See, it's down now because the traffic will will drop because we're sending it to our um, we're black holing it. So if we will remove it, no, let's see. This one it auto update every 5 seconds. See, it's up now. You saw those two that you can go investigate those one. See, you can see there are two drops. See, this is how I work. This is how it works. The ping portal. It's very helpful. For example, if you want to search, let's say you want to search only Teams, you can search Teams, apply. You can see, let's say you have 100 ping portal continuously. This is very helpful. And I recommend this one for your point-to-point connection between your provider, for example, Rogers, Bell, Shaw, right? You SSH your router from your Linux box from our tool, then it will initiate IPSLA. So for example, if there's an issue, um, you can go back in time. For example, let's say what was the normal traffic for for the last 7 days, right? So if we can go back to the last 7 days. Oh, this is the normal traffic for this. Um, See, you can see the graph. But if something is going on, for example, there's some spike, continuously spike from the graph, that means there's something wrong on that ISP, right? Then you can call the ISP, hey, what happened to this link? Why the issue started on this date, right? This is very helpful. This ping portal is very helpful in case of an issue, right? So that is our ping portal. Then we have also we have also in our ping portal, right? We have respond time RTT. So in our RTT, it's around trip time in milliseconds. So in our graph here, 50 milliseconds, like a local, healthy. That's healthy. But if it's more than if it's for the internet, for example, at the internet, 150 milliseconds going to the internet is still healthy. That is our, but in our case here, I put 50 for the yellow marking, 100 is for the red. Then we have also status, right? We have up and down. You can see recently when we shut down that route from that 4.2.2. So we have a real-time chart showing latency trends, color-coded status indicator, green up, red down, historical data with zoomable graphs, min, max, and average statistics. So business value here is where we are proactively alerting before user notice the issue, historical trending to predict capacity needs, SLA verification for service provider. In a real world example, right, when a remote office reports, for example, the network is slow, ping portal shows latency spiking from, for example, 20 milliseconds, it become 200 milliseconds, confirming the issue is in the network related, not application related. Okay, so our next topic is the trace route. All you have to do is right click this one and trace route. In our trace route here, okay, we have a network path discovery and visualization. While ping tells you if a destination is reachable, traceroute tells you how traffic gets there. Because we have also a Python engine running on traceroute. Then we SSH the router. These are our router. Then we execute traceroute, parse ops, and then store them in our MySQL. We have MySQL on this one. So we have a hop by hop path, for example. Let's check the teams. So in our teams here, let's put 1 hour. Okay. So in our teams here, okay, we have a per hop latency response time to each router. We can see how much, like how fast is this teams. We can see here we have 2.3 milliseconds, 10.7 milliseconds, 6.0 milliseconds, 6.3 milliseconds, and 5 milliseconds. And we can see here yellow, 72.3 milliseconds. There was a latency here, and then the last hop is 6.7 milliseconds. So we have also a visualization here. For example, routing changes over time, traffic shifted to backup path. We can see bottleneck, high latency at the specific hubs, for example, this one, and so on, right? So we have interactive path visualization with hub marker, then color-coded latency indicator, green, yellow, and red, historical comparison showing path changes. Then we have also, what is the business value for this one? We have a rapid troubleshooting for of routing issues, ISP performance monitoring, identify which provider is causing delays, peering analysis, see how traffic flows between network flows. What is the real world scenario here? For example, users, for example, in Europe, report slow access to US server. Trace routes shows traffic going to Asia. For example, the traffic is going to Asia, right? We can see Asia IP address here instead of direct Atlantic path, right? Routing issue identified and fixed, right? So that's how this trace route is very beneficial, right? You can also do a search here, for example, um, let's say you're searching for a, uh, let's say you want to trace, search Google. You can search Google and you can see, because this just an example, right? Like for example, if you have hundreds of trace route going on, yeah, you can you can do a search and you can do hop by hop and investigate. I also create a view all history here for for extra visibility, right? For extra details. For example, what time it happened, right? When you investigate, you check. Oh, the issue it happened at 7:06 and 10 seconds. So if I'll go here, oh, oh, there's no problem in the network. Everything is fine. So this is not a network issue. This is probably an application issue. See, this is how it benefits this. Uh, then you can go also next here if you want to investigate more in detail. For example, you can see time here. What are the time that like what time is the issue, right? So in our next topic, for example, we have also HTTP portal. In our HTTP portal, the purpose is it's a web application for performance monitoring. Maybe you're familiar in like Thousand Eyes, right? This is where we move from network monitoring to application performance monitoring. APM. So how it works, it has also a Python engine running service, and it has a HTTP request to URL, but this time the source will be my Linux server, the one that we are using. Then measuring timing, parts response is stored in MySQL. So in our example here, for example, let's choose 1 hour. Then let's select our mycanadalife.com. Um, let's wait. It will load. Um, mycanadalife.com, or we can select probably TD Bank, Easy Web, right? In our TD Bank Easy Web, for example, um, we have a DNS time 1.7 millisecond. That's lightning pass, and oh, it's Canada Life loaded now. So let's focus in the um, TD Bank. Okay, TD Bank, we have 1.7 milliseconds. DNS time, time to resolve domain, that's fast. Uh, Greater than 50 milliseconds, still acceptable. Then we have TCP time, 7 milliseconds. TCP time, TCP handshake duration, right? Then we have what TLS 18.9. It's SSL and TLS negotiation. This is very good. This is fast, right? Then we have this TTFB 377.7. This is time to first byte. It's a server processing, right? Then we have a total 1401. It's a complete page load. How much time it load, right? It's like a 1 seconds and 1.4 seconds. So for me, this is like a little bit slow. It's like the server need of time optimization, but from the network side, it's fast. See, DNS, TCP, and TLS, it's fast. It's for me, this is like a server issue. It's not a network issue. Um, so the purpose of this one, right? We have multi-metric charts showing all timing components, status budgets. We have up, down, and green, right? Up, green, down, red, and degraded, for example, yellow. So we have a summary of statistic with color coded with health indicators, filterable results by status or time range, right? What is the business value here? For example, end user experience monitoring, measure what user actually see, right? SLA compliance for web application, performance regressions detection, catch slow down before users complain, right? Capacity planning, identify when to scale resources, right? What is the real world example here? The HTTP portal shows, see, the HTTP portal shows 377.7, increasingly from, for example, from 377, it became 500 milliseconds over a week. The database queries are getting slower. The development team optimize queries, and the TTFB returns to normal, right? Those are the common scenarios. And so you can also do investigation here. You move your mouse, you can deep dive. We have also like a story here. You can do an investigation if you want, right? These are a very important tool. Okay, then the last one is my favorite. This is my favorite. It's the MTR. The MTR, okay, the MTR is one of my favorite. My trace route combines the best of ping and trace route, then adds IP ownership and geolocation, right? For example, let's select a 1 hour here, and let's choose, for example, TD Bank. See, in our TD Bank, okay, so it's same function. It has a Python engine running at the back end. Then it ran MTR from our Linux box and parse hops, geo IP lookup, cache results, then store in MySQL. So this is also a per hops. Yeah, you can see here per hop loss, packet loss at its router. Um, let's see, these are normal. Number four, number five, showing 100% loss. Probably they're not allowing a trace route in there. Probably that is a firewall, or they're not allowing a trace route so that it will not display their public IP address. Here we can see there's a color red here. There's a packet loss there. I put the post here because this web application, it always like every few seconds, it's a real time, it auto update. So for investigation, I post it. So we can see here, there's a atlas here. This is between 160 and 14. So this one, 160 and 13, 160 and 14 from here. See, there is a 409 milliseconds average. Yeah, this is high. That's why it's color red. So, so this is per hop, also for hop latency. It's a response time for hop, and it show also ASN autonomous system. For example, here AS577. It's a Bell Canada. And we have also AS 20940. So that means TD Bank, they use Scrubbing Center, Akamai. They use Akamai for their DDoS protection, web application firewall. Then we have also geolocation. So we have Canada here, right? Canada and Toronto. If it's not showing, it's not because we have a database in this one, we are caching them. Maybe that database it's not showing for those IP address, because what I did, I download all the IP address from MaxMind. You can download all the IP address from MaxMind and download it from your database. So what is the value for this one? We have like a vendor accountability. Prove You can prove which ISP is causing packet loss, right? Geographic troubleshooting, you can identify if the issue are regional. So peering analysis, see how traffic exchange between networks, and DDoS detection. Unusual routing patterns may indicate attacks, right? So in the real world, international users, for example, report slow access. MTR shows traffic going through the congested transit provider in London. Uh, then contact that provider with evidence of 20% packet loss on the router, right? See, that's how you will. These tools are very important. For me, I really like them. See, our website www.trainingtechlabs.ca. Um, we can load the latest here, so you can investigate what time the issue happened. For example, between 7 o'clock. These are the traffic, right? Our website. We are using F5 scrubbing center, right? They using AS352AT, and based on this graph, average latency 6.6, which is very good, right? So we have also Google here. In Google, we, for example, let's investigate the latest. We have 146.4 latency here on this specific trace route. Let's see what happened here. So, so there are so many information here, right? So Google, they use their own scribing center. Um, what about LinkedIn? In LinkedIn, let's check which scribing center they're using. Um, oh, they're using Cloudflare. This is their SN number. It's located in probably in Toronto. I'm not sure why it is XX. And My Canada Life. What is Canada Life? Let's check one of the. Okay, My Canada Life. They're using Google LLC, located in Kansas City. AS396982, right? These are very important and very informative information. I can give you a sample I can show you how to, I'd show you how to add, right? How to add in in the ping HTTP targets. For example, which one you want to add? Let's say you want to add which website we're going to add, for example, Facebook. Let's put Facebook here, and then we'll put the name, Facebook. Okay. 200, expected status 200, interval 5 minutes, timeout 10, SSL verification, yes, follower directions, add HTTP target. This is target successfully. Okay. So in our HTTP, HTTP, we have Facebook at down. We need to restart the service. HTTP, let's check if it's running. Okay, HTTP is running. So let's try to restart. Okay, so let's see if it's working now. Let's put 1 hour. Okay, we have data here. So see, Facebook DNS is 119.81 for the TCP and TLS 6.4. So we can go deeper here. 1 hour. So Facebook is a little bit slow from this one. Let's see what is the next. Then let's go to MTR. For MTR, let's add MTR. For example, we'll add MTR target. Let's add Facebook also, right? Destination, TCP443, add MTR. Then Facebook is added. Okay. Now let's try to restart our service for MTR. MTR, restart. Okay. MTR status. MTR is running. Okay. So let's check MTR. Facebook. Okay. So Facebook, they use their own. I'm not sure if maybe they have their own scrubbing center. See, we can see hop by hop here using Facebook, right? So I hope that you enjoy this video and I hope they enjoy this tool. Um, Thank you for watching and see you on my next video. Bye.